All right. Here we go again with another recording. Welcome again to another lesson. Today we're going to do digital art in pixels through CodeHS. I like digital art. It's similar to what something I took in college with digital logic and just making sure that pixels are assigned to different numbers and stuff. Anyway, I'm getting ahead of myself. I gave this assignment to my students yesterday when technically I gave them 2 days to finish. It's really an hour-long assignment, but I wanted them to have some time and be creative with it. So today I'm going to run through the essentials. I've been kind of on the fence on whether or not to play the videos or not. So far, YouTube hasn't struck me down, so we'll see.
Hi. In this video, we'll be talking about how computers encode images. So here's a question. How exactly are images stored and displayed on computers? We know that at the base of it, computers are only storing zeros and ones. It's not like we can really take an imprint of that image and burn it onto a CD. We need a way to represent an image as only zeros and ones. So really, we just need a system of breaking down an image into concrete values that can be stored. We know we can store numbers with binary, so that's really what we need to do, is find a system for turning an image into a sequence of numbers. We need a digital representation of an image. So how are we going to do that? Well, introducing pixels. Pixels are the building blocks of digital images. A pixel is the smallest element of a digital image. It is like the atom of a digital image. So if you look at any image on a computer and you zoom in really close, what you end up seeing is that there's actually all these tiny squares, each of which have their own color. From a distance, everything looks like smooth lines. You can have gradients, you can have depth, you can have shadows, but when you zoom in really close, it really just boils down to tiny, tiny squares, each of which have their own color. So we see that an image can really be represented as a grid of values, where each value encodes the color for that position. There's a grid of pixels, and each pixel has a constant color. So really we just need an encoding system where each color can map to a particular value. So what's an encoding system we can use? What's a good table that will map values to colors? Well, the simplest system would just be 0 being black and 1 being white. The 0 is off, there's no light, and the 1 would be a white because there is light. Just using this, we can make several pixelated images of black and white. We can add complication to the system later, but for now, let's just practice making images using only zeros and ones, black and white images. Let's explore this in the editor. So welcome to the bit interpreter tool. We see that this time, the bits are being interpreted as colors rather than text. What's interesting is the bits are the same. We're always using zeros and ones. It's just a matter of the software. It's a matter of whatever program is interpreting these bits. That determines the actual results, what is displayed on the screen. So here we see the encoding table says that 0 results in a black pixel and a 1 results in a white pixel. Again, we can view the raw format. It's all in one line, or we can go pretty, and we can see each row here represents a full row in the resulting image. So we just type a 0, that's a black, and a 1 is a white. And we can make full images like this. So I want to add one more layer on the bottom just to make the computer nice and stable. We see we've made the CodeHS logo using only black and white pixels. So this is one way we can make black and white images.
All right. So let's go ahead and get into it. So they gave us the one example to look at. Let's go here. I hit my mic. No, I don't want to replay you. Go back to what we were doing. Oh, I just hit continue. That's why. To explore this example, note that the way that the lines are shown up in the pretty format, you can technically see where the differences are. If you look, like if you squinted your eyes, you would see how the design changes. But note that computers read this a certain way. You have a system in place where you have to tell it here in the metadata that I'm expecting this many rows and this many columns. And then you fill in that data accordingly here. Now, what happens if I take away this 1? As you can see, it shifts everything after that point. So this helps us with isolating where the digital image is. And notice I just put a 0 there instead of a 1. So it makes that one part black. Notice I can keep doing this again and again, get the shift that I want. Do note that we're not actually, so by doing this, as you can tell, is just extending the visual down, extending the code down. However, because our metadata has dictated that 21 and 21 are not to be trifled with in some way, that's what I should say. We're not going to see past it unless we tell it. I pointed at my TV screen. Unless we tell it here to show more than what we're given, it's not going to go past a certain point. So we can do this all day and move the image down again and again and again and again. But it doesn't mean anything if the metadata doesn't show it. Think about the Super Mario 3 scrolling effect. Alright, so now that we have a good idea, let's look at how they did the checkerboard example. So, the thing about the checkerboard is, again, you have the alternating black and white spaces. And so I like to challenge my kids and say, hey, what if I wanted to start the checkerboard the other way? I would X this off. That's not there anymore. Bring that here. It's still waiting for me to put that other row back in. And it's still the checkerboard. I just took the first line down and shifted it. So now the white space is the starting square rather than not. Test cases here. I don't think they actually showed us nothing. They just wanted us to see it. Right? Okay, so then they wanted the ladder example. In this exercise, create an image of the ladder. It has a height of 20 and a width of 5. Height of 20, width of 5. And it should look like that. Where's the image again? Alright, so we want to look like this. Height of 20, width of 5. So 1, 2, 1, 2, 1, 2, 1, 2. Cool. So let's go ahead and set this up. We go back to the code. As you can see, our metadata is going to fit where we want it to fit. Right now, as it were. So again, I wanted to say, that, sorry, my other screen's this way. So 1, 2, 3 there, 1, 2, 3, 1, 2. Okay, that's totally fine. So let's get this in piece by piece. So we have two verticals and then the rung. So the rung is essentially every third line. If I'm counting it out, 1, 2, rung, 1, 2, rung, 1, 2, rung. This is just something I can say or do to keep myself steady. So if the rung is every third part, and then we cut off that last line, because then if we set it by 3s, then we'll get to 21 and we won't really see what we want. So here, the good thing about this is that they're going to fill it in for us in real time. So let's do, that's 1. That's 2. And then my rung should be here. Oh, let's see, Mr. Clark is almost messing up. My rung needs to be visible that way. Now, I say it again, and I'm gonna say it to my last breath. Computer scientists, especially when it comes to coding, are inherently lazy, and we try to find shortcuts at any given moment. My teacher used to say that as well. So, Control V, Control V. Oh, formatting issues, huh? Control V. Hit your enter before you hit space. Here we go. Alright, so that line 21 is not going to show for us regardless. We would submit and continue and see how well we did. Boom, boom, boom. Everything correct. Ba-bam, 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 ba-bam. Shout out to my digital media students. You know what it is. So now we're going to take it a step further and we're going to add color to this. I believe we're using the RGB scale. Got the Goku move going on back here. I'm going to stop doing that. YouTube.
Hi. In this video, we'll be learning about how we can make pixels with color. So we've seen how images are made up of pixels. Pixels are the tiny little squares, each of which have their own color, that come together in a grid, such that when viewed from a distance, the image looks smooth, and it looks like it has curves and lines. It's all made up of those tiny little pixels that are tiny squares with one constant color. So, to make an image digital, to represent an image with numbers, an image can really just be represented as a grid of values, where each value encodes the color at that position in the image. It encodes the color for that pixel. So we've seen the very simple system of just 1 bit per pixel. 0 means black and 1 means white. And this is great when we want to make simple black and white images. But what about color? RGB encoding scheme allows us to encode colors as numeric data. And the way it does this is it defines the amount of red, green, and blue light in a pixel. This is where RGB comes from,
So
red,
RGB
green, blue.
values come into play.
The idea here is that any color can be created by combining red, green, and blue light at varying intensities. The way this works is
Play
each
video
pixel
games,
gets
you definitely
3
know this.
values. 1 value for red, 1 value for
Your
green,
window
and 1
menu
value for blue.
customization thing.
And putting those 3 values together makes a color. So if we have 0 for every channel, then we have no light. We have a black pixel. If we have some mix in between, say we had 156 red, 54 green, and 255 blue, that gives us purple. And if we have them all the way up, if we have 255 for every single channel, that's how we get white. We max out each color to its max intensity, and we get a white pixel.
Presence of all light.
So each color channel gets its own value in the
Presence of
range
all
from
paint
0 to
turns black.
255.
Something I tell my
This is the
kids.
minimum and maximum value for any pixel channel, RGB.
Light
Let's
versus
explore this in
paint.
the editor. So here we're back in our bit interpreter, and now we're interpreting bits as color pixels as opposed to black and white pixels. We can still go back to interpreting as black and white if we want, but this is going to completely change the scheme. Right now, these first 8 bits encode the entire picture because we only have 1 bit per color. So I can change this first one to a 1, and it'll end up turning white. But if we want to interpret as color, it takes a lot more bits to represent a single color. So here, these first 24 bits are encoding black. This next, every channel is on. We have all 1s for red, all 1s.
Oop, no. I accidentally pressed the wrong button.
Ones for green, all 1s for blue, so that's going to be white. Here only red is on, so that's going to be red. And here only green is on, so this is going to be green. If we ever want to figure out how to make a color that we don't know how to make using bits, we can use this color picker over here. So just dragging this around, you can see what string of bits maps to what color. You can drag this up and down to get various colors, and drag this around to get various brightnesses. So let's try to finish out our image by trying to create every color we can possibly make by turning channels all the way on.
I believe they
So
let
we've
you
made red
copy
and
the
green.
key there. We'll find out
How can we
in
make
just a
blue?
second.
Well,
I think for the sake of the argument, we'll move.
255, the maximum value for blue. So we want a 0 for red, a 0 for green,
Oh.
and a
oops.
255 for blue. So that's 8 ones.
Bookmarks.
Awesome, so we made blue. We can also switch from binary to hexadecimal, and this is going to make typing a lot easier for us. So here, instead of 8 bits per color channel, we have 2 hexadecimal digits per color channel. So these first 2 encode red, second 2 encode green, last 2 encode blue. So that's why this pixel is red, this pixel is green, this pixel is blue. So we've tried combining red and green. What if we combine green and blue? What color is that going to be? We'll turn red off, green on, blue on. So that made cyan, and that makes sense. Here we see right in between green and blue, we have cyan. All right, now it's your turn.
All right. So we hit continue and we move on. Sorry, I had my second screen up. For this example, they have this one where they used black, white, red, green, blue. They made yellow because it's all red and all. Hold on, did I say that right? Black, white, red, green, blue, yellow. Well, their golden color came out mostly all red and all green channels. Let's see if that makes sense. Wait. Why is the key not writing it right? It's out of order-ish. That's fine. I mean, I can't necessarily find the right say. Maybe I did. We'll see. Well, essentially, that's what that is. I feel a little fidgety today, but that's totally fine. We're gonna be just all right. And then you have your magenta-ish, that is purple, and then your light blue here to make those smaller colors. So checkerboard letters, color pixels, colors and bits. Wait, we already did that. So we're gonna save and continue. We're gonna make our own. So what do they want us to do? Display the red pixel. I'm on exploring RGB. Try adding a blue pixel to the screen. Alright, so how do I add a blue pixel? So the way that this is read in red, green, and blue, the first two channels will denote for red, and by channels I mean the bits that they represent. Because they're writing it in hexadecimal as opposed to binary. Binary is what we saw before. Hexadecimal is a base 8 system, so you use less characters to show the same amount of things. Same amount of information, I should say. So to do blue, we would put in no red, no green, and all the way through on my hexadecimal Fs. So hexadecimal is a base 16 system, 0 through 9, and then 10 is A, 11B, 12C, 13D, 14E, and 15F. Whoa, did I count that right? A, B, C, D, E, F. There it is. So 10A, 11B. I skipped someone somewhere. 11B, 12C, 13D, 14. Oh, 10, 11, 12, 13, 14, 15. Oh, yeah, 15 is F. Because you're starting with 10. That's why. That's what sounded wrong. So that's what threw my numbers off. Anyway, I got it. Mental lapse there. I forgot to count 10 as a different number than what was on my hand. So 15 is the value of F before it starts over again. And that's where I was tripping. So, let's go. This will be a great video. Alright, so we have the blue one. Looking at a few errors, you should keep going. Your image should have a height of 1 pixel and a width of 3. So height should be 1. Width should be 3. So we just take down our rows. Boom. So we change our metadata so that it matches what we want. There we go. Boom, boom. And we're done. Alright, so now represent 3 standard colors. Challenge problem to make the color yellow. So how do we make the color yellow? Alright, so this is our last one. Let's see if it's FFFF. Zero? Yeah. So again, when you put in all of your red values and all your green values, you get your yellow. You think about the color wheel and things that you see. And really you can look right here, because in the dead center of where green and red are, where they meet in the middle is kind of yellowy, yellowish, however you want to interpret that. So we should be able to save and continue. Boom, boom. Again, this lesson doesn't take that long at all. I want to see how well my kids did with it. So we're going to make an RGB rainbow. So first we need red. Are we doing binary for this, or are we doing hex? I'm going to do hex. We want red, orange, yellow. Alright, run code. I'm going to get my key. Maybe zoom out a little. Maybe that'll help. So I'm gonna get some red, as much red as I can. Oh, and you can copy it, so that makes your life a little easier. We get my orange. Orange is my favorite color. And you think I actually do. I usually have this one memorized myself. I think it's the more brighter orange that I prefer. It's FF6600. Personal choice, personal matter of preference. Let's see how we're doing so far. Right dimensions, you must use at least 6 colors in your rainbow. Alright, yellow should be... I'm trying not to do this without... Alright, that's FFEE, but that's close. I want FFFF. So maybe FFF. Almost. We'll just put FFFF. Oh, and then green should be FF. Oh no. 00 FF 00. Almost there with the rainbow, right? So then we do blue. Blue is one of our main channels. 0000 and simply FF. And then purple is the last one. I don't remember purple all that much. Not off the top of my head. But I'm assuming it's going to be somewhere similar to FF00. FF? Yeah. Although that's not my preferred purple. I go for LSU purple. If I can, and if I can swing it. This is our little rainbow. I want to submit. I want to close this. I want to look at it again. So again, it's just matching where you think those mixes should go. And I tweaked this a little bit to make my preferred color of orange. Yeah. Actually, let me look at this. If we change it there, it just turns yellow again. So 6 or 8. Wait, is 8 in my thing? Yes, it is. 9. How about 2, 3. I guess that's more reddish orange. 4. Oh, that's the other thing I wanted to point out. So your computer's only going to read what it's been given. So notice if I take out these values, it's going to read in a different format. So it's reading this as FF0000 red, and it's reading FF00FF, which is a purple again, and it's reading everything off center. So even if I put one of these here, that helps, but I don't get my purple bit because it doesn't read it partially all the way. So maybe that should help make sense. Let's go. We're going to create a pixel image. Mr. Clark wants to do something. Alright, so think about this. I'm going to go ahead and create one real quick. I'm going to make it nice and easy. Let me see. I'm playing this out first. How am I? 10 by 10? 1, 2, 3, 4, 5, 6. Wait, I am 10 by 10. So then we're going to do 1, 2, 3, 4, 5, 6. Yeah. Alright. 1, 2, 3. 1, 2, 3. Wait. 1, 2, 3. Skip. 1, 2, 3. Skip. 1, 2. I might want to change my metadata here. Because if I do, I give myself some more rows or columns. If I give myself another row, nope, I want to give myself another. Nope, I don't need another column. I want more rows. That's right, I want to read this better. So why, if oh, it has to be even. Okay, so I like to manage 12 a little bit better. Alright, so think about how I want to plan this out. And I'm going to make this really short and simple once I get it. This is going to be, this is hex, and every 6 things should be aligned. Cool. I can do this. Okay, so if we're doing hexadecimal, I want to find, alright, I'm going to interpret as, I don't want it black and white. I want to find my right shade of, technically that will work. You also hear dogs in the background. I apologize. I have dogs, or we have dogs. So maybe. Oh my gosh. All right, so I'm gonna go back and replan this out so I make sure I do this right. 1. All right, I have 12. So now that I have 12, 2 up and 2 on bottom. That's 4, and then that's 8. So that's 8. And I do 12. I can do 3, skip 1, 3. Wait, can I do 1, 3, 1, 3, 1, 3? Ah, but that would throw off. I should have planned this a little better. So 1, 2, 3 would give me enough to be like, hey, I got this. 3 here, 3 there, 3 there, and then I have 1 extra. All right, we're just gonna go with this. So I also need to go ahead and find my particular shade of purple that I enjoy. That darker LSU purple. I don't know. It's like, of course I'm going to LSU, right? I'm just gonna say, I like. You know what? Let's see. LSU purple RGB value. Because sometimes we have it. Aha. Okay. Let's be super specific about what we're doing here, folks. So, voila. So that is LSU purple right there. I'd say that's about right. Oh. It's pretty formatting. Let the pretty formatting do it for me. Alright, and then I gotta find LSU gold RGB. Wait, I can just click the link because it'll tell you. So our specific color of gold is FDD023. Yay, Google. Because you already know what I'm about to do. I'm about to do this number right here. And probably not as specific as that, but we're just going to, you're going to get the point across. So this is going to have not a billion lines. It's 12 by 12. So it's going to have 144 when it's all said and done. So because I know I want this again, and these are the only two colors that I'm dealing with, because I'm keeping it simple. You ever follow the KISS principle? My teachers in high school would tell me to do the same, so I will. Alright, so 2 up and 2 down. Fix my formatting. 2 up and 2 down. Which would mean... Alright, so... And then you have here... See how I want to do this. Am I good with this? Am I good with this? I might be good with this. So I really was going to do them letter by letter, but if I do them wholesale, this will go a lot faster. So as I see the image start to form the way I want it, and watch, something in the metadata is going to throw me off because I didn't practice this beforehand, but it's fine. I go here, here, here. I realize what we're doing. All right, 1. Is it there? Do I want to do that way? All right, so I'm counting this out. When I count this out, I get my L is going to be 2 spaces. I should just make... No, because then I would have done... Well, how bad would this throw me off? Made it a little bit bigger. Kinda. Alright, I have stuff to work with. You know what? Everybody deserves more space. Copy. Alright, so now that we're on 13 by 13, I can give each letter their proper spacing. Again, that probably might be the rest of this video, but I'm going to figure this out. 1, 2, 3, 13 by 13. So I'm going to take the scratch paper and really go to town. For each individual letter, I want a space of 4 of each individual letter. So 4, put a space between 4, put a space between 4. So 4 times 3 is 12, space between, so it should be 14 by 14. Let's go, Mr. Clark. I just said the name of the channel. All right, we're gonna figure this out. It's gonna be great. But the framework is there. I just had to make sure the metadata added up. All right, I already had purple. Should we do this again? All right, so 4. Whoa. Something I did there. Oh, I took out the 4. No, what's happening? Oh, my enter key. I accidentally hit it. That's what happened. And now when I do 461, I put it back in. Alright. Alright, so back here. Now where was my first instance of gold? Ugh. I almost said yellow. I hate. Alright, pet peeve. I hate when people say that LSU is purple and yellow. And some people do it just to irritate me, but it's okay. They'll be alright. We learn to love them, right? So 4 letters. So this would be a gold right here. Once I get this down to what I want, we're gonna be all right. All right, so you're gonna see in just a second. This is gonna be a purple. Then, whoa, Mr. Clark, what are you doing, buddy? You know you should be making the S before the U. You know it. S. Oh, I didn't time out the what you gonna write? That's gonna be awkward. Okay, so if that's 14 on top, then where am I gonna put the switch? I'll make it work. It's fine. So 4 letters, then switch. So you're back to here. It was a very crude imagination, crude sketching of this in my head, and I'm just trying to make it make sense to me. So 1, 2, 3, 4, blank all the way down. 1, 2, 3, 4, blank all the way down. 1, 2, 3, 4. All right, so I'm gonna take this section of code because I know it's good. I'm gonna copy it. I'm gonna change it and put the purples on the inside. We're gonna do another similar assignment to this very soon. I'm actually gonna play a game with this. We're gonna do the formatting. Here we go. All right, so do I have? All right, there we go. Okay, at this point, I'm like massive, pretty rewrites. I want that U section again. I should have remembered where it is. Technically, I do, because it's right before. It's gold, purple, purple, gold. So if I look back to about right here, to where it says gold, purple, purple, gold, which is technically right here. Copy this, bring it down. All right, and that's there again. This might actually continue for a good little bit. So let me make that back to the pretty formatting. Where does that gold start? So the latest row was here. And there were 4 golds. So gold 1, 2, 3, and 4. Cool. So this whole copy right here should take me down to what I want. And let's see. Yeah, okay. Okay. Alright, I am 4 rows deep, which means I have 14 to play with, 2 on top, 2 on bottoms. So 5 rows deep. Alright, so right here is where I'm going to do the awkward S switch. So right there, I'm going to go back to pretty formatting. So in this row, I need to find where the S is and make that switch. These 3 are going to be switched to which home? So it should be gold, gold. Before that third one come back up. Gold, gold. Here is where you should be switched to gold. I'm going to copy you. Before I shift everything else off, boom. I'm literally going to copy it in place so it doesn't shift everything and throw everything off. So the metadata, if I had chosen odd number, I would have had a good spot to switch it from. But this is fine. Post to me. This is fine. Alright. So everything is good. Now, here's the thing. I'm now going to use that same line of code that I know I have. I should have kept track of it. Oh wait, do I still have it? No, I don't because I copied it. Alright, so where is before this line? That was there. Before this F here. So really I could have done math to see where I am in the row. 1, 2, 3. Alright, 1, 2. I'm counting by the yellow squares. 1, 2, 3. Let's see what this does. Sorry, I can't answer your call right now. In the middle of streaming. Okay. That almost does what I want. Actually. Where are you? You just need to be purple and you're good. No, you need to stay gold actually. Where's that gold at? We're going to change you to a purple. If it wasn't for this L switch, we'd be alright. Copy. There we go. So now we can finish the rest. Good. Alright, and then I put the U back. Let me go find my U shape. I need gold, purple, purple, gold. Here, that's a good section to take. Gold, purple, purple, gold. Copy. Keeping it nice and simple. Should have done something in orange. Maybe I should have done a logo. It's gonna look like... Oh, Mr. Clark. Alright, so I did 4 for you, designated spot, 4 for you, designated spot, and 4 for you. It's gonna look awkward. It is. It's just, that's just the nature of the beast. Alright, so I'm gonna take Now that I finished that row, I can finish it out the rest of the way. 1, 2, 3, and then all the way back up to this guy. Copy. Yay, shortcuts. One more? Alright, cool. Nope, I gave them 2 on top. Okay. So, let's make this last change. The last thing is 1, 2, 3, 4. You guys need to make more gold for the L. So we're gonna take you. We're gonna take you. And we're gonna take you, because I totaled 4 each. Again, right? Work smarter, not harder. We're gonna keep that purple. We're gonna take you, because I gotta put the S back together. It isn't an S unless that's together. And then the last one. So this is the one row with the most amount of gold. And then the rest, my friends, is simply purple all the way through. Whoa. Messed up. Almost messed up. Oh, wait. You noticed something, didn't you? I mean, I noticed something. I'm gonna go finish that in just a second. Alright, go to pretty formatting. I go to pretty formatting. Again, this is 14 by 14 is 196. So then I do 14 minus 28. I'll show you 196 minus 28. We're going to do some math here. 20 would be 170. Take out the 6. You get 168. So if I go to 168, let me see. Let's see if I did this right. So this should be the last of my stuff before the purples. Really, I just had to look for that. I just wanted to do the math and flex a little bit. So what needs to happen here, I'm going to copy you. I'm going to put right here. And last but certainly not least, right here. All right. So I guess really I should have done this 15 by 15. What would happen if I made this 15 by 15? Everything would get shifted, and then I would make it work out better. Huh. Where am I at on time? Because I'm doing this a little too much. So technically the lesson stops here. But, I mean, I could change it that way. No, because then I would have to do 16 and everyone gets their border. I mean, all of my golds are in place. Yeah, that's the thing. All of my golds are in place. It's just where do I want to place my purples so that this shifts correctly? You know what? We're going to do it, and then I'm going to be done. All right, this won't take long at all. Just an extended thing. So I'm going to take here. I'm going to shift where I want. I mean, you guys got to see the finished product. I'm just going to go a little and make it make sense. Copy. I just need more purples, that's all. So now that I'm working with one color, I can shift it where I want. Cool? Yeah. Alright, yeah, so I did give that one the right one. Alright, you still get 4 in the middle, 4 there. So where the 2 yellows coincide. Why am I saying yellow? Don't say yellow. That's not what we do here. Is it right here that I want to split? Yeah, I do want to split there. And there. Cool. So I have one row done. Cool. Let's shift it right. So then this is here. Where is this at? Alright. It's 16 by 16, right? So this one I would actually do math. My first 4 rows are done. 4 times 16 is 40, 64. So we don't start until number 64. Alright, cool. That shift is there. So if I shifted that there, I now need to shift the next set. So what would have been 64 then Oh, I can always just throw a test number in there. Alright, that's the white spot. I don't want it there. Don't overcomplicate things. Just push another purple through. Alright, we want... Nope, I'm a little too soon. Nope. Not there. Remember, do it before yellow. There we go. Oh, it's always before yellow. I can... okay. Alright, if it's always before yellow, I gotta make sure it's the right yellow. Oh, it's always before this yellow. Nope, not that yellow. Different yellow. Alright, nope, not before that yellow either. There it is. Found it. I was a little too ahead of myself. Alright, so you were there. Oh, that's that yellow, huh? It's a little higher. There it is. Nope, that's not it. Pull out. No, it's in between those. Or not. It's just, yeah. Always in between. Always in between. So find one where I still could have done the odd man out and made this make sense with the L switch. Wait a minute. I made it originally. We'll see. I might change where the S is. Pretty. Where were we? Kind of got lost in translation here. All right, so 16, 16. how many rows are done? The first 1, 2, 3, 4, 5, 6, 7. 7 times 16 is 17, 42. 70 and 42 is 112. Right here. What happens if I throw a purple in here? Alright, that disjoints that. We don't want that. There we go. Is it here? Nope. In between. Yep. In between. I'm starting to catch it now. There it is. 1, 2, 3, 4. I got a little nitpicky to finish off the hour, but essentially we're done. It is not exactly center spaced, but we can change that actually. Watch this. Everything shifts. Boom, and we're done. The raw code is gonna read that many bits, and then there we go. Everything's nice and neat. So I got to play with pixels and colors. That's about an hour. This was an hour of code, and I'm gonna save it because I'm gonna come back to it. Submit and continue, and hopefully I can go back and save it because I want to go back and take a picture of it. My good hard work. Yeah, alright, cool. So it's saved still. I'm going to take a picture of it and post it in my Google Classroom for my kids. Thank you for coming by, and if you like what you see, subscribe to the page, I guess. Tell your friends. This is not just for my students. If you'd like to use this material as well. Big shout out to CodeHS. If you don't know, CodeHS, codehighschool.com. They've been giving teachers full access up until June to their pros subscription. So you have the full layout and get the, you can grade the assignments in there and things like that. So, thank you for coming and have a great day.